Hello guys, welcome back to my YouTube channel. Today we are going to solve this Leetcode question, which is amount of time for a binary tree to get infected. Let's dive into the question. In this question, we are given a root of a binary tree with unique values. Means in this binary tree, all the values are unique, and we are given an integer start. And at minute zero, at zeroth minute, an infection starts from the node with value start. And for each minute, a node becomes infected if the node is currently uninfected and the node is adjacent to an infected node. Return the number of minutes needed for the entire entire tree to get infected. We need to return the number of minutes needed for the entire binary to get infected. This question is easy to understand, but the problem is uh, no, the solution is very difficult. Okay, let's try to understand the question first. Initially, there is one node which is infected by some sort of coronavirus. Let's assume let's assume this three got affected by a virus, and then what the question is stating is, for every minute at minute zero, this guy has got infected, and for every minute, this guy will infect the neighbors of him. At first minute he will affect this guy, as well as this guy at the first minute. And on the second minute, this 10 will infect all its neighbors, this 6 will infect all its neighbors, and this 1 will also infect all its neighbors. For 10, there are no other neighbors. 3 is a neighbor, but it is already infected. So there is no point in infecting him again, right? Because of this guy, he got COVID. So there is no point again infecting him with the same virus, right? So 6 also cannot infect any other one. And if you look at one can infect this guy at second minute, and 5 can infect this guy at third minute, and 4 can infect these two guys at the same time at the fourth minute. Means we need 4 minutes to infect all the guys in the binary tree. We need to return this value. That's it. If you look at this example, we only have one person and this person already got infected. So at 0th minute only he got infected, right? So we need to return 0. So let's look at the constraints. The number of nodes in the binary tree will be until 1 lakh, 100,000, and the node value will be from 1 to 10 power 5, and each node has a unique value. Each and every value inside a binary tree will be unique, and a node with a value of start exists in that tree. Means he is particularly mentioning that there is a person inside the binary tree who is affected. That's it. Let's look at some more examples to get a better idea of the question. Let's assume we have. Let me draw this tree and come back. Now let us assume this is our binary tree, and let us assume that this guy got infected initially. At 0th minute, this guy got infected, and let's see how this virus spreads among the binary tree. At the first minute, this guy will get infected and this guy as well. So in the first minute, these two guys have got infected. And in the second minute, this guy will get infected, only this guy. And in the third minute, this guy will get infected. And in the fourth minute, these two guys will get infected. And in the fifth minute, these two guys will get infected. And in the sixth minute, this guy will get infected. So to infect the entire binary tree, we need 6 minutes, right? So let me take another example. Okay, now let's look at this example. Let's suppose this guy got infected at 0th minute, and on the first minute, these two guys will get infected. In the second minute, This guy will get infected because of this guy, and this guy will get infected because of this. At the first minute, these two guys got infected. In second minute, these two guys got infected, and in the third minute, these two guys got infected. Right? What if there is another guy here? What if there is another guy? At the fourth minute, this guy will get infected. Right? Uh, this is the guy who got infected at 0th minute. Now, if you look at this example carefully, it will take 1 minute to infect this guy, and it will take 2 minutes to infect this guy, and it will take 1 minute to infect this guy. It will take 2 minutes to infect this guy, 3 minutes for him, 3 minutes for him. For him, it will be 4 minutes. So our answer is also 4. So if you observe carefully, what we're doing is, from the guy who got infected, we'll just travel in each and every direction. We'll travel in this direction, and in the parent direction as well. And we'll take the maximum of these three directions, and that is our answer. You look at you look at this example. If you go to the left, there is no children, so he cannot affect anyone. So it will take for him 0 minutes. If you go towards the right, it will take for him 2 minutes. But if you go onto the top, it will take for him 4 minutes. So our answer is 4. Hope you got some sort of idea of this question. Let's look at another example to get a clear idea. Now let's look at this example, and with this example, you'll get an idea of how this thing is working. Initially, let's suppose this guy is affected at 0th minute, and in the first minute, these two guys will get affected. In the second minute, these two guys will get affected. First minute, second minute, this guy as well because of this guy. The second minute, and in the third minute, this guy will get affected. Right? We're taking 3 minutes. Why? What's the reason we're getting 3 minutes? The distance from the one who is affected at the beginning. This guy is the one who got affected in the beginning, right? So the distance from this guy is 3. 1, 2, 3. If you look at the other side, the distance to the leaf node is only 2, right? 1, 2, 1 and 2, right? And if you look at this direction, it is 1, 2 as well. But in this direction, it is 3. So we'll take the maximum by traversing in each and every direction. Now let's suppose I'll come back with another example. Now let's look at this example. Let's suppose uh, this guy, this guy got infected, right? Now now what you'll do is, you'll traverse in this direction. Let me take another color. You'll you'll see, how many steps for this guy to reach the leaf node. It is 1, and from here to here it is 2, right? And if he goes in this direction, it is taking for him only 1 step. But if he is going to the top towards its parents, it's taking 1, 2, and in this direction it is taking 3. But if you come in this direction from 1, 2, and if you directly came here, it will take 3, and it will take 4, right? So the maximum amount of time that we are taking is 4, right? So what we need to do is we just need to find the maximum distance from this guy to each and every leaf node. If you look at this path, it is 2. The distance is 2, right? If you look at this path, the distance is 1. And if you look at this path, the distance is 1, 2, 3, 3. Now if you look at this path, the longest path, the the distance is 4, right? So this is our answer. That's it. what we need to do is there is an infected guy with us. There is an infected guy with us. We'll check in the left child direction. What is the distance? And we'll check in the right child directions. What is the distance? And we'll check in the parent direction to get what is the distance. We'll take the maximum of these three and we'll written it as our answer. Uh, that is the that is the logic behind this question. Now let's see how we are going to solve this with the help of code. One important point to note here is in a binary tree we can only traverse in the downward direction, right? From a from a node we can only traverse to its childs, but we cannot traverse in the opposite direction because we don't have a path in the opposite direction. So what we can do is we can create a map. Sorry for that. We can create a map which tells for every node we will get the parent of that node. Suppose for 5, what is its parent? It's 1, right? For 5 it is 1. For 3 it is also 1. For 4 it is 5. The parent of 4 is 5, right? And the parent of, sorry, 3 is already done. The parent of 10 is 3. The parent of 6 is 3. The parent of 2 is 4. The parent of 9 is also 4. What is the parent of 1? The parent of 1 will be, let's suppose, -1, or we can also keep as null, right? With the help of this map, it will allow it will help us to traverse in the opposite direction as well, right? From this node, you can go to 4 easily by referencing node dot right? Now, what if you want to go to the top? What you'll do is you'll ask the map to give the parent of 5. What is the parent of 5? 1, right? So, with the help of map, you can traverse in the this parent direction. So let's see how we are going to solve this question with the help of code. Before diving into the code, let me explain you how the code is going to work. Initially, what we'll do is, hello. Initially, what we'll do is, we will create a map which contains the parents, right? Initially, what I'll do is I'll traverse the entire binary tree and I'll, store in the map the parents of each and every element. For this initial element, the parent is -1, and then what I'll do is I'll go to I'm sorry. What I'll do is here when I'm at 1, what I'll do is I'll for 5 I'll say the parent is 1, and for 3 as well I'll say the parent is 1, and then I'll go to 5. I say for 4 the parent is 5, and from 5 I'll go to 4 and I say for 9 the parent is 4, and for 2 the parent is 4, and I'll go to 9 and I see that it does not have any children, right? So I'll not do anything. I'll go to 2, it does not have any children, so I'll not do anything. After finishing the left part, I'll go to the right part. After going to 3, I'll say for 10 your parent is 3, and for 6 its parent is 3, right? So this is our hash map. With the help of this map for any element we can get the parent. For 3 the parent is 1, right? For 3 the parent is 1. For 9 the parent is 4. For 9 the parent is 4. Like this we will be creating the map, and after creating the map what we're gonna do is, let me erase this. Now what we are going to do is, this question, we know that 3 is the one who got infected, right? So what we'll do is we'll go to 3. We say that from 3 we'll go to 10 and we ask 10 to get the maximum length to reach the leaf node. Is 1, right? So this will return 1 for him, and we'll call for 6, and this will return 1, and we'll also call for its parent, for 3's parent, right? What is the 3's parent? 1. From whom we are getting the parent of 3 means we're getting it from the map, right? So it is a recursive call. Let's see how this thing works. Initially, just a minute. Now, what we're going to do is initially we'll call three three different recursive function calls. The first function call is we'll call for this infected persons dot left, which will be we'll call for 10, and we'll use a set in order to say that 3 is already visited and don't go back to 3 once again, right? And we'll also call another function which will be 6. We'll call for 6 and we'll say that 3 is already visited, don't go back to that. Call for call for 1 as well, right? In the 3 directions we're going to call for 1 and we'll say that 3 is already visited, don't go back to that. Now from 10 we'll call for left child, right? If we call for left child, it is null, right? And we say that 3 comma 10 are visited, and for this going to call the right child. For 10 the left child is null and the right child is also null, so I'm going to call for null and I say that 3 is already visited, 10 is already visited. And from here I'm also going to call its parent, which is 3, right? But can we call 3? Cannot call 3 because 3 is already visited, right? If you look at this, what this function returns is 0 because there is no one in this direction, right? So it will return 0. This function will also return 0 and this function will also return 0 because 3 is already visited. So there's no point in visiting 3 again. So these 3 will return 0, and what this function will do is it will take the maximum of these 3 and add 1 to that, and this will return the value. The maximum of these 3 is 0. 1 plus 0 is this will return 1. And now let's explore this thing. Now what this function will do is it will also call 3 members, right? It will call 6. What is the left child of 6? It will call null, so it will return 0. We know that, right? On the right child, we'll call null. What this function will do is we'll call null and it will return 0. And this function also calls its parent, right? When it 6 calls its parent, it is 3, right? We're calling 3. But 3 is already visited. 3 is already visited, right? So it will also return 0. So the maximum of these 3 is 0 and it will add 1 to this and it will return 1. Now let's explore this function call. Now let's explore this function call. This function call will call function of for 1. It will call its left child, which is 5, comma. Will say that 3 is already visited, 1 is already visited. So don't go back to them. And it will also call function of its right child, which is 3, right? 3 is already visited. So this will return 0 directly. We know that. And it will also call function of what is the parent of 1? What is the parent of 1 is minus 1, right? So it will call minus 1. And when minus 1 means there is no parent, right? So it will also return 0. Now let's explore this function call. It will also call three members. The first one is its left child, which is null, right? Null means this will return 0, we know that. And it will call its right child. What is its right child? 4, right? Call 4, and it will say that 3 is already visited, 4 is all, I'm sorry, 1 is already visited, and 5 is already visited. So don't go back to them. And you'll also call its parent, right? What is the fifth pair? 5 parent, 1, right? You'll call 1, but 1 is already visited, right? So this will return 0. We know that. Now let's explore this thing. We'll call three things. Function of what is 4's left child? 9, right? 9. And it will say that uh, 3 is already visited, 1 is already visited, 5 is already visited, 4 is already visited, 4 is already visited. So, and it will also call its right child, which is right child is 2, right? 2 comma 3 visited, 1 visited, 1 visited, 5 visited, and 4 visited. And it will also call its parent. What is its parent? Fourth parent is 5, right? 5. But 5 is already visited, right? So this will return 0. We know that. Now, when we come to 9, we see that it will call its left child, which is null, will return 0. Will call its right child, which is null, will return 0. Will call its parent. What is nine's parent? 4, right? 4. But 4 is already visited, so it will return 0. We know that. We know that it will take the three values and take the maximum of those, and it will add 1, and it will return 1. What is the value? The maximum of these three is 0, and 1 plus 0 is 1, right? So this function is returning 1, this function is returning 0. This function does the same thing, right? So this will return 1. Will take this function, what it does is it will take the maximum of these three, 0, 1, comma 1. What is the maximum? 1, right? It will take the maximum of these three, which is 1. 1 plus 1 is 2. So this will return 2 for this. And what is the maximum of these three? 2, right? 2 plus 1 is, this will return 3. And this function will take the maximum of these three, and it will add 1, and it will return 4. If you look at this diagram here, this function is returning 1, this function is returning 1, this function is returning. So our answer is 4. Now if you look at the code, now you'll get an idea, right? uh, Actually what we're doing, let me change this. Okay, what I'm doing is I'm creating a hash map which contains the parents, right? Parent, right? And I'm also creating a target in order to find which, node is infected, right? So what I'm going to do is initially I'm going to traverse the entire binary tree, and I'm going to create this parent hash map as I already explained you before, right? I'm going to create this hash map, and after creating that, I said that we will be maintaining a set in order to identify which nodes are already visited and which nodes are yet to be visited. Initially, we'll be adding the target. Target is nothing but this thing, the one which got infected initially, or if you want me to, if I can say infected. Infected, and what I'm saying doing is, as I already explained, I'm going to call three recursive calls, which one will be to the left child of the binary tree, One will one will be for the right child of the binary tree, and one will be for the parent of the binary tree. And I'm going to take the maximum of these three values, and I'm going to return the value. Now, if you look at this function, oh, oh wait. Now, if you look at this function, we're doing the same thing that we are doing here. What we're doing is, if the root value becomes empty, we'll return 0. And if the set already contains a value, we'll return 0, as I have already explained here, right? I have explained here. The the root value becomes null, we'll return 0, right? The root value becomes null, we'll return 0. And if the value is already present in the set, we'll also return 0, right? So that's why we're returning 0. And initially we'll be adding the current value to our set, and we're doing the same thing that we're doing here. We're just calling for the left child, we're calling for the right child, we're calling for the parent, and we're taking the maximum, and we're adding 1 to that, and we're returning that. That's it. If I submit this, it will run perfectly fine as I have already tested it. But oh, okay. Since I have changed the name to affected, I need to change every position. I run this to change it. Hold on. See, yes, it got accepted. Let's submit the. Yes, it got accepted. I know this is not the efficient solution, but it is one of the solution that I came up with. If you like the video, I haven't watched any other video in order to come up with this solution. And if you like this video and found some valuable insights, then go ahead and like that, click that like button. Thank you.